Lesson 116, quotient rule for square roots. All right, we are going to do what's called rationalizing the denominator. So you don't want to have radicals in the denominator, or square roots. Those are radicals, okay? We don't want those in the denominator. So first of all, I have the square root of 3 halves, and I want you to change it to the square root of 3 over the square root of 2. That means the same thing. You're square rooting the entire fraction, or you're square rooting the top and the bottom, okay? It means the same thing. And then we do not like that there is a square root in the denominator of the fraction, okay? So we are going to multiply by itself. And I'll explain why, okay? So first of all, whatever is here, that's what you're going to multiply by. Now, I have to do it in the top and the bottom because what is this actually equal to? It's equal to 1, and anytime you multiply by 1, you're not changing the value of what is there. So it's legal math, okay? And the reason that I want to multiply by this exact same thing is because what am I going to get underneath the house there? I am going to get the square root of 4, which is 2. So I'm making it a perfect square so I can get rid of the radical, all right? So if it's the square root of 3, you're going to multiply with square root of 3, which will give you root 9, which gives you 3. So you're getting rid of the radical by multiplying by the exact same thing. All right, and then the top here, we would get the square root of 6, multiply those. And then we keep our square root of 6 because it's okay to have radicals in the numerator. And then on the bottom, the square root of 4 is equal to 2. That's my answer, okay? And that is called rationalizing the denominator. That's what we call that, when you get rid of the radical, okay? Let's try another one. The square root of 1 over the square root of 2. All right, so we're going to rationalize the denominator, which means getting rid of this root. So we're going to multiply by whatever's in the denominator on the top and the bottom. So this gives me the square root of 2 in the numerator. And this gives me the square root of 4 in the denominator. And the square root of 4 is equal to 2. And that is our answer. What if it looks like this? Okay, so write down 4 plus the square root of 5 all over the square root of 3, and it just says simplify, which means rationalize the denominator and simplify. All right, so I want to get rid of the square root of 3 right here. So what am I going to multiply by? Over the square root of 3. Okay, because this is really equal to 1. So in the top now, you guys, we have to add parentheses. So when you multiply by this root 3, it needs to multiply to both terms, all right? So I have the square root of 3 times 4, which is 4 root 3, because this is an outside number and that's an inside number. And then when I multiply this to this, they are both underneath the house. So that would be the square root of 15, all divided by. And the square root of 3 times the square root of 3 is equal to the square root of 9, which I'm just going to put 3, okay? All right, and that is your answer because it does not simplify any further. If 15 had a perfect square, you would take it out, all right, but it doesn't, so you're done. Let's try one more. 4 plus the square root of 3 all over the square root of 2. What are we going to multiply this one by? Root 2 over root 2. Okay. And in the top, what do I get when I multiply this to this? 4 root 2. Okay. What do I get when I multiply this to this? Root 6. Good. And in the bottom, I'm going to get what? Yeah, square root of 4, which is 2. This one also does not simplify. I do want to show you something. If it looked like this, would this one simplify? Yes. If all the outside numbers are divisible by 2, I can go ahead and divide this into this, which is 2 root 2, and I can divide this into this, which is 1 root 6. Okay? If all the outside numbers have something that they're divisible by, you can reduce it. Okay? Let's try some whiteboards. That was pretty easy.